Assalamualaikum and good day. So we are going to go to the second part of the chapter 1, part 1 lecture. Okay. So I would like to do some recap from the previous lecture. So we learned about what is a system, learn some introductions, what is signals, okay? What is a system, okay? Where it modifies or the signals or extract the further information. So that what is a signal processor. Okay. In other words, it is a generator of signal or it is a transformer of signals. Okay. Next, we learn about type of signal. We learn about continuous time and discrete time signal. We learn about analog and digital signal. We learn about energy and power signal. We learn about deterministic and probabilistic signal. Okay, deterministic a signal that can be known, and probabilistic signal is a signal that happen in random. For example, noise. And then we learn about harmonic signal, which is the repetitive signals. And then we have even and odd signal. Okay, even correspond to symmetric signal, and odd signal refer to this anti-symmetric signal. Okay. So this is the examples of the figures. So now we go to the second part of the chapter 1 and part 1 lecture, which is the signal operations. Okay. So time-based operations and amplitude-based operations. So we have these two types of operations, main operation for our signals. Okay. Time-based operation is that the operation is happen on our time axis, which is our horizontal axis. Okay, it can be time inversion, it can be time scaling, it can be time shifting. So you can have either one, or you can have either two, or you can have either three of them. Okay, so this is happen at the horizontal axis of our signal. So so when we have an axis, okay, if you can see here, you can have an axis. So we have here is x, okay, this is y, okay. um, this is the normal axis that we know, generally known. So now we have, if you want to consider signal axis, okay, here for example, here is our horizontal axis in time. Okay, you can have in either frequency or time, and then you have here is the function of the signal. Okay, because here is t, then you should have a function of inside here is inside of t. Okay. Sorry if you guys heard a noise, some noise in the background. Okay. So this is the origins. Okay. Make sure I always remind students to actually to have this zero. Okay, it's seems like not important, but actually it is significant. So your time operation will be happen along this horizontal axis. Okay, this horizontal axis, which is the time operations. Okay, so you can have three types, which is the inversion, scaling, and you can have shifting. Okay. Next is amplitude based operations. Okay, amplitude based operation is happen along the vertical axis of our graph. Okay, which is just now is the, for example, is ft. Okay, so it happened along the vertical axis. So it can be amplitude inversion, it can be amplitude scaling, it can be amplitude shifting. It can be either one, it can be either two, it can be all three. Okay, then here the same, imagine the same graph. If you have time and you have ft, so it will happen along the vertical axis here. Okay, vertical axis here, the amplitude based operations, whether it's amplitude shifting, amplitude scaling, or amplitude inverse. Okay, then of course when we learn about these operations, either in time based operations or amplitude based operation, we can have addition and multiplication of signals. Okay, means we can have combinations of two individual signals or three individual signals. Okay, so this is possible. So now we go to this time operation, which is the first operation, which is the inversion. Okay, here, inversion. So if yt is a time inverted signal for xt, okay, so what does it mean by this? Means that your original signal, okay, your original signal is xt. Okay, and what is t? Why we put t inside the bracket? Mean this signal is dependent on t. Okay, dependent on t, which is dependent on time. Okay, then yt is a product of this xt. Okay, in this situation, the yt is a time inverted signal if you have, for example, yt equals to x negative t. Okay, as you can see here, we have negative in front of our t. Okay, so this means that the signal yt is actually a time inverted signal of xt. Okay, and if you see here, the operation is happening inside the bracket t, mean the operation only happen in time related to time, which is our horizontal axis. Okay, so for any time, for any t, which is equals to t naught, okay, which is equals to our t naught. T naught is actually, we refer to, t at initial time, or okay, something like that. Okay, we can have later on t1, t2, t3. Okay, so t1 is, we can regard it as like for the starting t. Okay, so here we have y in bracket t naught equals to x negative t naught. Okay, so this means that our time t naught, okay, and yt is actually an inverted time signal of xt. Okay, and then and y negative t is actually equals to xt negative 0. Okay, if you can see, they are interchangeable like this. Okay, so here if you refer to the first graph, okay, first graph at the left, okay, you can see here is xt. Okay, you can see here is xt, and you can here see at the right side of the right figure, right graph is actually yt. Okay, so you see here xt is actually, when you inverse it in time horizontal axis, you obtain yt. Okay, so what is actually can be summarized with the time inverted signal is that as if you put a vertical mirror here. Okay, as if you put a vertical mirror here. Okay, so when you put your vertical mirror here, okay, there will be time inversion happen. Okay, time inverted signal happen. So if you put the mirror here, obviously, okay, so let me try to draw it for you to make it informative. Okay, new. Okay, so the initial signals, okay, which is our xt, okay, which is our xt, you have here is the original signal, the shape of our original signals. Okay, you have two here, you have one here, and then you have one here. Okay, this one is obviously zero. Okay, I always remind my student to always remind yourself. Okay, always make it a habit to write zero here. Okay, it's origin. Okay, you have -1, then you have a -2, then you have -1. Okay, so this is your xt, your original signals. Okay, then you have a yt. Okay, then you have a yt, which is actually yt. So yt, which is a time inverted signal. So I put it here in red so you can see it clearly. Then you have here t. Okay, so this yt is actually time inverted signal. So as if you're going to put a mirror, okay, on the vertical axis here. Okay, as if you put mirror, it's here. Okay, it's here in the middle. Okay, so what happened is that, okay, we draw a new okay, the new graph here. Okay, then you have the same time domain here at time. Then here, be careful, you should write it y t equals to x and -t. Okay, write it, make sure you write it correctly. Otherwise, even if your graph is correct later on, okay, your image is correct but your axis is wrong, then you can get a reduction in your marks. Okay, so your mark won't be full. Okay, so imagine that now we have a mirror here. Okay, I just put here a mirror. You just imagine there is a mirror here. Okay, then what happened to this signal? Okay, here we see this part first. Okay, so we put let me use orange color. So you have here, right, this one. Okay, so the value, the amplitude doesn't change. Okay, remember when we have time inverted signal, solely on time inverted signal, we don't have any other combination operation. Okay, mark my word, there is no other operation on this signal, only time inverted signal. So in this case, there is no amplitude changes. Okay, your amplitude should be the same, only there is changes in your time. Okay, in your uh time element signal, which is your horizontal axis. So now we have, imagine we put a mirror here. Okay, then you just invert. So instead of you have one here, you will have here is -1, and then you have here is -2. Okay, the amplitude here doesn't change, so it's still one. Okay, sorry, it's still one here. Okay, then we finish with this first part. Now we see the second part. Okay, the second part is that you invert as if like you have mirror in the middle. Okay, similar case. Then you just continue like this. Okay, so likewise there is no changes in your amplitude, only in the uh time expect in the horizontal axis. So the value here should be the same, which is -1. Okay, and then here you can see it's -1, but now you have time inverted signal, so it should be 1. Okay, then you have here -2, so it should be 2 here. Okay, so this is your yt. Okay, this is your new signal yt, which is a time inverted signal. Okay, time inverted signal. So remember. Okay, next. Okay, next is we go to time operation. Okay, time operation scaling. Okay, time operation scaling. So what is scaling? In if you see by the word scaling, I mean there is potential changes in the size. Okay, in the size of the signals. Okay, in the size of signal is you know, to make it simple for you to understand, in the size of the word. So in the size of the signal, there will be changes in signal, whether it's going to be smaller, whether it's going to be bigger. Okay, smaller means that is it going to be compressed, or bigger is if it's like expanded. Okay, but this operation happen as well in along the horizontal axis. Okay, the changes happen along the x-axis because it is a time operation. In this situation as well, there shouldn't be any changes to the amplitude. Okay, there shouldn't be any changes to the amplitude. Amplitude should be the same. If it's for example in this graph, you have maximum of 1, so your amplitude should be maximum of 1, but you can have your changes in your time in your horizontal axis. Okay, so here, if you can see, signal xt, which had a time scale of a, is given by, okay, here you can see that you have yt equals to xat, where a is actually a real constant. So a is actually a number. So you can have a equals to -1, a equals to 2, a equals to half, but it is a real constant. Okay, so you can have here. So if you have y equals to xt, what does it mean? It means that your a is equals to 1, so y equals to xt. So let we consider example 1. Okay, we have here is yt equals to x2t. Okay, if you can see that your a is actually equals to 2. Okay, your a is actually equals to 2. So imagine the original signals. Okay, this one, the most left. Okay, you have y equals to xt. Okay, which is your a is equals to 1. Okay, then the right side of the right side is yt equals to x in bracket 2t. Okay, so here, if your magnitude of a greater than 1, okay, it means a time compress. Okay, it means a time compress. So if you can see here, it is described in magnitude. It is described in magnitude. Not means that we at this time, in this condition, we didn't consider whether it is positive or negative. Okay, as long as the magnitude greater than 1, the magnitude. Okay, for example, if you have x equals to 2t, or you have x equals to -2t, we will consider the magnitude only, which is 2. Okay, that's why we use modulus here. Okay, we only consider the magnitude. If you want to consider the negative or positive, this one is the which is inversions. Okay, inversion. So now we only consider uh, the scaling aspect. Okay, for this session, because previously we have learned about the inversion. Okay, now we want to learn about this scaling. So scaling, we only see the magnitude. Okay, so if you can see in the modulus here, it's 2. Okay, so 2, if your a is greater than 1, which is in this case, a is equal to 2. So obviously your a will be greater than 1. So what happened if you have this kind of a which is greater than 1? Your signal, okay, your new signal will be compressed. Okay, will be compressed in time. What does it mean is compressed? Mean the signal will experience speed up. Okay, it will be faster. So here, if you see, okay, the original signal here, if it here is 1. Okay, here is 1, t equals to 1 second. Here is t equals to 2 seconds. Okay, so if x in bracket 2t, so it is speed up by twice, something like that. So here 1 will be divided by 2, which you're going to have half. Okay, so let me show. Okay, I'm exit the screen first. Okay. Okay, so imagine our original signals here. Okay, let me draw it. Okay, 1, and then here is 1. So this is your original, which is original signal, which is which is y equals to xt. Okay, y equal to xt. So here is 1, and here is 2. Okay, so means that this one is 0.5. Okay, okay, and then here is -1, and here is your -2. Okay, so what happened is that when we have we consider the case of time scaling, which means that there will be changes in size. Okay, whether it is smaller or bigger. If it's bigger means slow down, it is smaller will be compressed. Okay, compressed, which means speed up. Okay, so yt. Okay, here is y equals to xt. Okay, the next case is where you have x equals to, for example, 2t. Okay, now we can see here too. Okay, if we take the modulus, which is the modulus means that always positive, because we only consider the magnitude. Okay, so 2 here is 2. Okay, 2 is obviously greater than 1. If this a, which is 2, greater than 1, okay, the signal will experience time compress, which is speed up. So the signal will be faster. Okay, so in this case it's faster by uh, is twice as fast. Okay, so what happened is that okay, let us consider the new graph. Okay, xt here, sorry, t, and then remember, write it probably. Okay, don't make mistake in write the function of the graph here. Yt equals to x 2 and t. Okay, so now you need to change the scale, but your scale changes only in horizontal axis. There's no changes in amplitude, remember. Okay, but later on, when as you study in later sections or later chapters, okay, of course we have some combining effects. Okay, but this one is we only focus solely on the scaling, the time operation in terms of scalings. So if you see, there is no, in the time operation scaling alone, there is no changes for the amplitude, because our changes is only in the horizontal axis. Okay, so if you can see here, okay, this is the original signals. Okay, so you're going to have time compressed. So for example, okay, 1 will be 1 divide by 2. Okay, easy for you to understand. Okay, I want you guys to easy to understand. Imagine, okay, where is actually this a causing the effect of the scaling. The next is this one is 2, so 2 over 2. Okay, which is 1, right? Okay, 2 over 2. And then the next we have here is -1. Okay, over 2 as well. Okay, then the next is what? -1. So here, okay, of course, this is just for your understanding. You don't have to write like this. Okay, so later on you can just write this one as, for example, this one you can write is as 1. Okay, and then you can write is as -half. Okay, this guy. So this is just for your understanding. Okay. Okay, oh my god, what is this? Okay, so now you can see this one is actually having amplitude of 0.5. So here you can see amplitude doesn't change, so 0.5. Okay, so I put the in black color for things that doesn't change. Okay, here. Okay, and then the next one is 2 here. Okay, the amplitude is still the same, which is 1. For example, here. Okay, so you have here, if you can see, doesn't experience any changes in the amplitude, right? Okay, then similarly for this one, okay, you just continue. It is here. Okay, so this is the answer. If you look into my drawings, okay, as if they are the same, okay, but I was just showing what is the I was just trying to demonstrate to you, okay, but actually the real graph, okay, would be look slimmer, okay, will be slimmer, the new signal, okay, slimmer because it's time compressed, so it should be like this, okay, compared to this one, okay, it should be like this, okay, but it's okay, okay, if we're going to do some sketching, as long as your value is correct, okay, value is correct, okay, so you should get mark for that, okay, so because when we do some sketching, our scale of course is not correct, okay, but the important thing is make sure that the value of the whatever value that you plot to your graph, okay, is right, so shouldn't be any problem that you should get full mark, okay, just make sure that you write everything correctly, okay, and sketch it properly. So there we goes about this our time operation scaling. If our a is actually if our a is greater than 1, what happen if our a is less than 1 now? Okay, so okay, we take a new graph, a new drawings. Okay, now we consider the second case, which is also the second case of time operation scalings. So now we have y equals to yt, okay, equals to x 0.5 and your t. Okay, so you can see that your a here, okay, your a here, which is you remember I said take the modulus, which is only the magnitude, so your a is actually 0.5, okay, which is less than 1. So at this situation, what is happen to the signal is that the signal will experience what we call as time expanded, okay, it will be expand in time in the horizontal axis. So what the implication of this is that the signal will be slowed down, okay, will be slow than the original, okay. So let us imagine, okay, the graph that we have, the initial one, the same like in the first situation just now. So we just imagine the original signals. Okay, here is your one, here is your two, here is your one, okay, so remember this is your t, okay, this is your xt, okay, then you have negative 1, 0, then you have negative 1, then you have negative 2, okay, so this is the original signal, okay, which is y equals to sorry, this is a signal of xt. Now we try to consider the next case, okay, y t equals to x, okay, okay, so here is a less than equals to 0.5 less than 1, so it'll be expanded in time, okay. So what happened, okay, here, for example, here it will be 1 times 2, okay, and the next will be 2 times 2, okay, which is 4, and then here for this one sorry, I forget to put in red color to make it difference. Okay, and then the next one is -1 times 2. Okay, and then the next one is -2 times -2. Sorry, times 2. Okay.
Sorry, I didn't get that.
Okay.
Could you ask me again?
So I think you you guys overheard. My Siri is responding to my voice. Okay, ignore it. Okay, so where were we? Then you have here 0. Okay, 0 times 2 still 0, right? So no changes in the origin. Okay, now let us consider is you see here there is no changes in amplitude. So you should have the same 1 here, for example, and then you should have the same -1 here. Only changes in your signal. The only changes in your signal is the horizontal axis. So if you see here, okay, it is just you can draw the resulted scaling time scaling signal. It is just the same like this. Okay, so obviously if you do in graph you can see the different you can see the changes in the size of the signal. This one is for me to help you to demonstrate what is actually happening. Of course this new graph should be much bigger than the original signal by twice the size. Okay, because this is 4, this is 2, this is -2, this is -4. Okay, so it should be twice as big. Okay, next next we go to time operation, which is the last operation, which is shifting. Okay, what is shift means your signal. Okay, your signal will be moved shifted either to the left or to the right. Okay, if it's moved to the left, okay, it means that your signal will be advanced. Okay, for example, instead of t equals to 0, now your signal move to t equals to -3, so it will be advanced, mean it will be speed up. Okay, it will be speed up, I mean it will be earlier. It's not speed up, it means that it will be advanced. For example, if you can simply imagine like this. It will be go it will be in for example, if you have event A happen on 4 p.m. for example. Okay, so if you have time operation shifting, for example, then your event A, instead of happen at 4 p.m., it will be happen at 2 p.m., much earlier. Okay, so if it's shifted to the right, okay, it means that it will be at time delay. So instead of your event A happen at 4 p.m., it will happen at 6 p.m. Okay, so this is just a analogy, so to make you understand what actually happened in our time operation for shifting. Okay, so here, if you can see, okay, a signal xt which has a time shift of t naught, okay, t0 is given as yt equals to xt minus t naught. Okay, then this is your signal. So okay, don't worry, I will show the demonstration later. So this is imagine you have this signal. Okay, um, where you have a -1 amplitude at 0, time equals to 0, then you have time equals to 1, you have amplitude at 3, then from t equals to 1 until t equals to 3, so the time is so the signal is decreasing in amplitude. And then for t equals to -1, t equals to -1, you have amplitude of -1, and then t at -2, you have amplitude of -1, and from -2, -3, and -4 and onwards, it will be 0, for examples. Okay, so here, if you can see, if you notice, there is the writing like this: y t equals to x t minus t naught. So there will be time shifting happens. So when we want to see whether it is shifted to the left or shifted to the right, okay, you should make a bracket inside here. Okay, you should make a individual bracket inside t0. Okay, inside t0. So if you make a bracket here, then you will see that, okay, I think I will demonstrate it to you, so to make you guys understand, okay, better. Okay, let me consider the, okay, whole graph. Okay, okay, where were we? I'm where were we? Okay, we are, okay, shifting. Okay, if you see, okay, if you see y, okay, okay, if you see y here, then you see in time, okay, y dependent of time, dependent, okay, not independent, dependent of time. Then you have your x, then you have your t, okay. Then straightly you just write like this, okay, like this, t minus, then you have t naught, okay, just like this. So that for easy for you to make the distinguish whether this one is time delayed or it will be advanced, or in another words, whether it is shifted to the right or shifted to the left. Okay, so here you make a separation like this, some distinguish, you make some individual bracket. Okay, so here you can see that this, okay, this is causing your shifting in your signal along the horizontal axis, which is the time, okay, value. Amplitude, again, there's no changes in your amplitude, still remain the same. Okay, so here your t is actually a constant, a number. Okay, for example, you can have t naught can be 1 second, can be 2 second, or can be, for example, -3. Okay, and can be any value, constant. Okay, so imagine this our original signals. Okay, our original signal, let me draw first. Sorry if my drawing is not that good. Okay, I'm not a born artist. Okay, not a born painter whatsoever. Okay, if I can draw good, I mean, if I have talent in drawing, I might not be a lecturer, I think. No, no, I'm just joking. Okay, so never mind. I just, okay, let me see. Okay, I tried my best to make it the draw look okay, I think like this. Okay, where, okay, so here is our, this is the original signal. Okay, 3, then you have 1. Okay, then here you have what, here you have 3, and then you have -2 here. Okay, here is your time, and then here is xt. Okay, okay, I hope it's clear. Okay, look, boleh lah, cantik lah juga. Okay, -1 here. Okay, so this is your original signal before any modification. Now we will consider two cases. Okay, of course we consider two cases where yeah, okay, let me use a bit more colorful representation so it'll be attractive. I hope. Okay, okay. So we have two condition to see here. Okay, so if your t now if your, we consider the first case, which is your t0 is a positive number. Okay, if positive number. So what happened if you have your t0 is positive? Okay, here. Okay, inside. Okay, not outside. Okay. Remember, you put the negative, distinguish, okay? You make it individual bracket, so negative is actually outside. Okay, so if your T0 is positive, for example, if your T not, okay, for example, just for example, T equals to 1, T equals to 2, okay? So your signal, okay, in this case, before I proceed with the drawings later on, okay, you can see this here, the writing should be later on y equals to x. If this is 1, so x t minus 1, okay? Or, okay, just like I told you guys to make an individual bracket, you can see this actually t minus 1, okay? I hope it's clear now, okay? Okay, so that is the case. So you can see is t positive. So this is actually how it's described as t positive, okay? Okay, so now let me erase it. Now we try to demonstrate what these changes in time shifting effect in to our signal, to our new signals, okay? Okay, so now let's us consider, okay, let's say our time signal is t naught is positive and it is the value is 3, okay? The value is 3. So imagine that, oh, this is eraser, okay? So imagine that t naught is 3 now, okay? T naught is 3. So your writing should be y t equals to x t minus 3, okay? Then x equals to t minus 3. Okay, this one is just for your understanding. Sometimes even though it's look like additional effort to make to do the writings, but you sometimes you can you make less mistake. Okay, so now you have t equals to 3. Okay, this case. So what happened at this time, okay, mean that your signal yt here, okay, it will be time delayed. Okay, means it will be time delayed and the signal will shifted to the right. Okay, first it will be time delayed. Okay, and then it will experience the shifting to the right. So it will move to the right. Okay, it will move to the right. So let's us consider the drawings. Okay, now the drawing, the sketching of the signals. Okay, so remember, it will, if the t is positive, it will experience time delay, and it will be shifted to the right. Okay. 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 So we consider these signals now. We consider these signals. Okay, the original signals. Okay. So what happened? Okay, first, just the same practice. You draw the graph first. Okay, you draw the graph first. Remember, you should have here t correctly, okay, correctly described, and this one should be correctly described as say y t equals to what? X t minus of 3. Okay, so now let me consider this signal now. Okay, okay, that we consider these signals. I put green color. Okay, you see here, initial value here is 0, right? So it will be time delayed and shifted to the right. So if 0 plus 3, what happened? 0 plus 3. So means it will be 3. Am I correct? 0 plus 3. So your 0 here, okay, your 0 here, okay, will be time 3. Okay. You'll be here 0 plus 3. Okay, and then you see, then you, how about here is 1, right? So 1, So 1 plus 3, it is 4. Okay, and then you have here, this one is 3 plus 4. Okay, sorry, is 3 plus 3. Okay, 3 plus 3, which is what, 6, right? 3 plus 3 6, so 6. Okay, so remember, there is no changes in your amplitude remains the same. So now let's we do the partial of the graph. Okay, the partial of the signals. Okay, what color should I use then? Never mind. Okay, I use orange. Okay, so here a3 is actually zero. It should have a value of -1 and 3. Okay, so that's why you draw here. Okay, so here is should be your 3. Okay, and here should be your -1. Okay, there is no changes in amplitude. And after that, okay, how about your 4 is actually 1, right? Here 1 plus 3 delayed by 3, so it still have value of 3. Okay, so you should have here. Okay, and then if you see from this part, okay, if you see from this part here, the signals goes down. Okay, so similarly it will goes down. Okay, now we finish with the half of the signal. You can say like that, half the signal. So now we see the other parts of the signal. Okay, which is the negative parts. Okay, you can see here -2. Okay, -2. So -2 plus 3, what is -2 plus 3? If you unable to do this calculation, oh my god. Okay, so -2 plus 3 is actually 1, so 1 here. Okay, so 1. Okay, okay, so again, there is no changes. There shouldn't be any changes in your amplitude, so it should be the same. Okay, just follow. Okay, so this is what happened. Can you see? It's actually the signal. Okay, when you have t positive. Okay, when you have the t positive, okay, your signal will be time delayed. Okay, and also it will be shifted to the right. Okay, shifted to the right. Okay, now we consider the next case. We consider the next case, which is when you have your t is negative. Okay, when you have your t is negative, so t not is your negative. Okay, negative. Then how is the representation? For example, we try to imagine if our t is actually t naught is -3. Okay, you can see the now we have a difference value of time. Just now we have +3, now we have -3. So then the representation, the signals, the new signals, say you have yt equals to x t minus, remember here minus, then you introduce again. Okay, this just to easy for you to understand and to make you, and you will do less mistake. Okay, then you have -3 here. Can you see that? Okay, then if you want to do some simplification, then you will see that x equals to t plus 3. Okay, but at least when you do like this, you will able to see that actually t is -3. Okay, so what happened is that when t naught is negative, okay, so your signal, the resultant signal, which is the yt in this case, is advanced. Okay, it's advanced in time. Okay, just like what I told you, instead of the event A happen at 4 p.m., for example, it will happen at 2 p.m. earlier. Okay, so when it is advanced, the signal will be shifted to the left. Okay, signal will shifted to the left. So what happened during this with your t is negative is that your signal will be advanced. and your signal will be shifted to the left. Okay, so the movement to the left. Okay, so now that we consider the examples, okay, but let me erase first so that we have more space for me to do my artistic drawings. Okay, sometimes I wish I wish I can draw better. Okay, not for me to be a painter, but sometimes it's a bit sad when you want to do something beautiful, but because you don't have talent in that, so you end up sakit mata tengok drawing sendiri. Okay, okay. So now remember again, I remind you guys to make sure you make the function, you represent the signal properly. Okay, yt so equals to x, t descent is plus 3. Why here just now? Okay, okay, we consider the same signal, the same signal. Okay, the original signal. Now I'm using just now I'm using green. Now I'm using blue. So here -2. Okay, now you have -2. So now -2, what happened is that -2 minus, okay, -2 minus -3, because it's -3. So okay, okay, let we see this first. Okay, to make it so that you can easily see what. Okay, for example, if your initial t here is -2, okay, and then you have what else? Okay, you should sample your value of t where the changes of amplitude happen. Okay, the changes of amplitude in, okay, here -2 is 1, -1. Then the next t that you have some changes in amplitude is 0, right? Am I correct? So it's 0. Okay, and then what else? And then you have 1. Okay, and then you have your 3. Okay, then the next one is that you have your t naught, the changes, right? The changes. So your changes actually in -3. So this is the the t. You can just put like this, t prime. Okay, t prime is that the new t. Okay, so here -2 plus 3. Okay, -2. Sorry, it's not plus, it's minus. Forgive me. So it's -3. Here, okay, it's -3. So you have the new value of time is actually -5. Okay, same goes for the rest of the guys. Okay, so 0 minus 3, you will have -3. 1 minus 3 is what? 1 minus 3 is 2. Is -2. Okay, and then 3 minus 3 is 0. Okay, so what you can do then, having that, you put here, now you have -5. Then the next is -3. The next is -2, and the next 0. Okay, so here you can see, okay, at -2, which is here, okay, you should have amplitude of -1. So let us draw, okay, -1. Okay, so here, okay, so how about the next one is a 0, which is -3. Okay, 0 is -3. At 0, I mean the initial time 0 is at t -3 now. Okay, however, you see at 0 here, at the initial, the initial, you can see at 0 here, example, you can have two value, right? -1 and 3. So here you should have two value as well. Okay, so one it adds -1. Remember, there's no changes in amplitude. And the next, okay, you have another value. You have another value which is 3. Okay, here. Okay, and then after that, you have 1 here. Okay, here. Okay, 1. Okay, which still maintains the same value. Okay, so there's no increase or decrease in the amplitude, so it should be the same. So here. Okay, and then after that, the value goes down, right? Just like the original going down. Okay, so it goes down, so goes down. Okay, here. So this is your resultants here. Now connect the dots. Okay, you see I'm using different material, and sometimes I do the points. It's okay, we can have many ways. Okay, but make sure that the answer still, it will lead to the same answer if your ways are correct. Okay, so you can see now, right? So you can see now is shifting to the left. Okay, shifting to the left. If your t is negative, means your signal will be advanced in time, so it will happen earlier. Okay, so hopes this clear. Okay, so maybe I'm not sure, maybe I'm going to what happened. Where is it? Maybe I will add this. Okay, my beautiful drawings. Okay, I will add to my slide. If you guys rasa macam sakit mata tengok lukisan saya buruk, buat tak nampak je lah you can go to the next page. Okay, this one you know effort ni saya melukis ni walaupun lukisan saya buruk kan. Okay, kejap I put it our slides. Okay, if you feel that it's too terrible for your eyes. Okay, too terrible to look at. Okay, just proceed to the next slides. Okay, okay, I'm adding to our slide. Okay, my beautiful drawings here. Okay, okay. Now what is that? Okay, a new. Don't save. Don't save because it's already been saved at the Google Slides. Okay, I didn't give you the slide initially because I will do some changes, right? So that's why I'm sharing a bit earlier. I noticed some of you were asking for the slides. Okay, no worry. My intention is that it's not that I'm purposely giving you the slide later than should be. Normally lecture will give you before, right? Or some lecture give you before. I give you sometimes you will notice that sometimes I give you earlier, sometimes I give you a bit late. Okay, if I give you a bit late, it's because I have some intention for the slide to have some amendments or changes, additions. So instead of you having the old slide without my changes, it's better you have a bit late but with my changes. Okay, that is my intention. Okay, so I have no other bad intention of why I'm giving late. Okay, you providing you the slide a bit later. Okay, so if you see now we're going to revise. Okay, revise. We have been we have learned, sorry, we have learned the time inversion, scaling, and shifting. Okay, we have learned 3 operations in time in the horizontal axis, which is inversion, scaling, and shifting. Okay, so practically, and this is not something special. Okay, signal can have more than one operation. Okay, occur to it. Okay, or can be all 3. For example, if you see here, signal axis will have both scaling and time shift. Okay, we consider if it's both scaling and time shift. Here we consider this example yt equals to x, at minus b. So you can see, right, the a here you have the constant here. So if you have different than 1, For example, if you have A -1, A 2, then your signal will experience time scaling. Okay. Then after that, you have some plus or minus here at the back. Okay. Means that this is correspond to what just now? Our time shifting. Okay. And A and B should be real coefficients. Okay. Not imaginary. Okay. Real coefficient. For example, -1, -2, 1 or 2. Okay. And then if A is negative, okay, here just now, if your A is negative, the signal will experience time inversions. Okay. For example, if you have your Y equals to X, okay, I should make it maximize full screen presentation. Sorry. So if your yt equals to x minus 80 minus b, okay, if a is negative here, then you can see that your signal will experience time inversion. Okay, and then at the same time, you have negative b here, means that your signal will also experience shifting. Okay, and then if you notice that you have a here, okay, if you have the magnitude, okay, remember, we only consider magnitude, okay, whether it is to be greater than 1 or less than 1. Okay, here in this sense that your signal, it will experience first time inversion due to the negative that you see here, and then it will have what time scaling, okay, due to this a, and then you have time inversion due to this b, okay, due to this b, okay, not negative b. Okay, remember just now I teach you guys to make it distinguish. There is the point why I in the first presentation of about time on the time shifting, I quickly separate them so that you can easily see. Okay, so there are three methods to obtain the signal yt, okay, which is scaling, shifting, and inversions. So this can happen. So please do it properly, the operation, so that you will get the end signal, which is the combination of the all the time operation involved. Okay, it can be one, it can be two operation, it can be three, even in the time domain in the horizontal axis. Okay, then okay, now for the combination of signals, okay, for the combination of signals means combination of operation in time, you will get to learn three methods. Okay, three methods where you can actually solve the signals that have uh, time inversion, time scaling, time shifting. Okay, combines. Okay, so there is three method. Okay, but I prefer that you guys to use method three, because method three is the safest one. Okay, and I will only teach method three. If you want to if you want to learn method one and two, it's okay. Okay, you can learn it as well, but I will not teach in this class. Okay, and method one and method two is that you need to do it correctly, following the step. If you do something incorrectly, not in order, for example, then or something else that you might do in mistake, you end up, get the wrong answer. With method three, it is the safest, and you tend to do, you will do less mistake. Okay, so this is method one, which I will not teach. Okay, you can try on your own. This is method two. Okay, method two, you need to do some factorization first. Okay, which I will not teach in this class. Okay, method two, we will proceed to the next one here. This one seems the safest, and although it's a bit, how we say it, I can say it's a bit time consuming, not really, but you will do less mistake. Okay, because you don't need to really think, oh, is it time inverted, or is it this, or is it this. Most really you will get the answer correct if you do it correctly. Okay, so we will go for this method three. Okay. So first what happened is that I first I will explain first, okay, then I will demonstrate, okay. Method 3. So the first step is actually you going to plot the original signal, but you will replace the time using the value of tau. Okay, you will use tau to replace your t. Okay, and then you consider consider tau equals to at minus t naught, and you solve for by having the t as the main equation is t. Okay, here I forget the mathematical terms you refer to this, but in Malay we call it perkara rumus. Okay, perkara rumus T. Okay, I forget English what is the word. I forget. Okay, and then plot T axis below the tau axis and plot YT on the T axis. Okay, so don't worry about this. Maybe you not be a bit blur. Okay, once I do the demonstration, I think it will be easier to understand. So, okay, let's see now. Example 6, okay, plot signal yt equals to x minus negative 2t minus 1 by using method 3 and signal xt as shown below. Okay, so exit full screens. Okay, um, sorry. Okay, let me. Now we are using method 3. Okay, so okay, I write first. Okay, the signal the instruction is that plot signal. Okay, I write it first. Okay, I try to make it as small as possible, my writing and my sketching, so that we can have all the information or whatever that I'm trying to demonstrate in one page. Okay, so we don't need to erase 8 page or something like that. Okay, I try to do that. So plot signal yt. Oh, okay, yt equals to x negative. Okay, I think I better use some a bit different in color so you can see, right? So here negative. Okay, just to make you easily distinguish. And then you have 2t. Okay, and then minus 1. Okay, of course the given question, of course, in exam, right, it won't do like this for you. This one I do for you for the sake of understanding. The exam they will certainly write like this. Okay, okay, with no any distinguish anything. Okay, this is just to make you understand easily, distinguish this. Okay, so the example is that it says plot yt x negative 2t minus 1 by using method 3, and then they provide us the same, they give us the initial graph. Okay, the initial graph, which is the same as what we have been using for our exercise just now. So let me draw first our the graph. Okay, uh, okay, this is the initial graph. Okay, okay, this is our initial graph. What is where was we? Okay, where is okay here? Okay, so this is the initial graph. Okay, then you have your t, then you have your xt. Okay, xt. Okay, then you have here is 3. Then you have here is negative 1. Then you have here is negative 2. Okay, then you have here is 1. Then you have here is 3. Okay, So this is the original signal without any having any time operations. Okay. Now they want us to, where is the question? Okay, to plot. Okay, to plot these signals. Okay, to plot the time operated signal based on this. Okay, this is the original signal. So what happened is that first, okay, you take this everything in the brackets. Okay, then you introduce tau. Okay, you introduce tau. So you take all of them in the bracket. Okay, like this. Then you make the t at the left and all of the other parameters or coefficient whatsoever at the right. Okay, I forget again, I told you guys just now, I forget the English terms for it, but the Malay term is perkara rumus. Okay, so perkara rumus here is actually t. Okay, so you make t here. Okay, of course you need to do some basic mathematics here. What here is negative 2t. Okay, and then you have tau. Okay, then you have tau plus 1. Okay, and then you have your t equals to tau plus 1 over negative 2. Okay, seems a bit seems a bit, it's better to separate them to make your life easier to see them. Okay, to distinguish them. So it is actually, okay, so remember, this one can be easily student, even the lecturers. Okay, we are anyone. Okay, if you, it's easy to make mistake. Okay, if about this minus and positive and negative, so make sure you do it correctly. Okay, sometimes we can put it basically, we put plus here. Okay, we put plus here. Okay, so now is our, this is our tau. Okay, you put your signal is all uh, in tau just now. The step one is the place the original signal but replace t with tau. So this is your step one. Okay, so then consider for t equals to at minus t naught and solve for making the t as the main of the equation like perkara rumus. So this is your second step. Okay, then the third step is you going to plot t exists. Okay, t exists below tau exists. Okay, t exists below tau exists. You understand that or not? Okay. Okay. Sorry, I'm doing some a bit stretching in the background. I think I've been talking like 1 hour. Okay, never mind. It's okay. Where was I? Okay. So now we're going to see this. We do some differentiation. Not we do some things here. Okay, if you see the time. Okay, let's say if you have your time. The original first is negative 2, right? Okay, negative 2, and then you have 0. Okay, and then you have what? You have 1, and you have 3. Okay, so this is your tau. Okay, where you replace just now, right? All this with a tau. So what is the resultants? What is the resultant t now? Okay, for example, the resultant t, which is here. Okay, so you put here inside the equation. Okay, so if you settle for this. Okay, you solve for this. So take your calculators. Okay, so negative 2 minus 2 over 2 minus 0.5. So it will be um, sorry, okay, negative 2 over 2 minus 1 over 2. Okay, so it will be negative 3 over 2. Okay, it will be negative 3 over 2. Okay, and then the next one is what? The next one is 0. So 0 over 2 minus, okay, 0 over 2. So everything with 0 over 2 is still 0. So it's negative 1 over 2. And then the next one is, what is the next one? Is 1, okay? 1 over 2. So negative 1 over 2 minus 1 over 2. Okay? So it is negative 1. Okay? And then 3, then tau negative 3 over 2 minus 0.5, which is half, right? So it's negative 2. Okay, I think I make a mistake here. Okay, sorry for that. Okay, so it's actually negative in bracket, negative 2 divide by 2. Okay, then minus by 0.5, which is your half. So it should be 0.5 here. Okay. Where was this? It should be 0.5. Okay. Uh, wait, I want to do some checking because this is recorded. You guys won't, you means I'm alone here. Okay, if I do mistake, then no one will correct me. Okay, so let me see first if I do this calculation correctly. Hmm. Hopefully I do it correct. Okay, let me see first. Okay. Okay, I guess it's correct. Okay. Okay. You see some silence there because I'm trying to check if it's correct. Okay. So now we go to plot 3, t exists below tau exists. Okay. So step 3 now. Step 3. Of course, if you see this is a bit slow, right? It's not, if you understand this, you can do it faster. Okay. I do this slow and steady so that you guys can see the picture. Okay, you guys can see it clearly, understand it effectively. Okay, hopefully. Okay, so I purposely make it slow. Okay, then now plot t exists below the tau axis. So this will be your tau axis. Okay, just now because you change it to all to the time domain. So uh, okay, so you do this. Remember the advantage of this method 3. Oh my god, what is happening? Okay, with this method 3, the tendency of you will make mistake will be what? You will tend to make less mistake if you're using this method. Okay, so now this one is in your tau. Okay, this is in tau now. Oh my god, sorry for that. Okay, plot t exists below tau exists. So now you have here, okay, the first is tau. Okay, wait. Okay, tau. Okay, now you're going to plot t exists. Okay, t exists below. So you have t exists here, below your tau exists. Okay, remember the first step is that you change all of the plot the original but replace t with tau. Okay, that's why we have this. Okay, we have this above. Then after that, you see, so you see your t. Okay, let me withdraw it again here. Okay, you can have 3, 1, 0, of course, here. Then you have negative 2. Okay. Then you have negative 1. Then you have 3. Okay. Uh, Sorry, it's not clear. Okay. So now you can see, right? T negative 2. Okay. If your tau is negative 2, what is the the mapping value of T now is actually 0.5. Okay. It's actually 0.5. So you have 0.5. Okay. And then what happened to 0? 0 will be negative half here. Okay. Will be negative half. Okay. Negative half. Then how about tau 1 is actually will be negative 1. Okay. And then 3 will be at negative 2. Okay. So don't wonder, why is the negative at the right and positive at the left? Okay. So this is actually, later on you will see that your time after what you do, your time will your signal will experience inverse shifting or scaling, or either of them. So this method 3 is the safest because when you do it, you actually indirectly solve for the inversion, scaling, and shifting if any of them is involved. Okay. But the method 2 and method 1 and method 2, you need to able to factorize and you need to able to identify yourself the inversion, the scaling, and also the shifting. Okay. So method 3 doesn't need that. Okay. So okay, now we want to solve, okay, our new graph, okay, in time. Okay, I think there is some just now there is some disconnection. Uh, I hope there is no. I hope they will manage to record. Okay, not sure. Okay, so now, okay, if you see here is negative 2. At here, negative 2, okay, you will have the amplitude at negative 1. Am I correct? At negative 1. But now your negative 2 is actually at 0.5. Okay, 0.5. Okay, so it be negative 1 here. Negative 1. Okay, and then at t equals to 0, okay, at t equals to 0, you will have corresponding value t time. Your time is negative half here, 0. So you actually have negative 1 and 3. So your resultant t is actually negative half. Okay, negative half. So you have two values, which is 1. I make it a different color so you can see. and 3. Okay. And then the next case of 1, here 1, okay, you have your t new value is at -1. Okay. But you see here 1, okay, at 1, what is the value? The value is 3. Okay, the value is 3. Okay. And then after that, the last one, 3, tau equals to 3, then you have the t is actually -2. Okay, so you have a -2. Okay, then you can see the initial tree, it is going towards 0, right? Is 0. So the same goes here, you have 0. Okay, now if you plot your signals, okay, if you plot your signal, you will have like this. Okay, so now you can see, right, your signal, this one, okay, this one, the original, compared to the one that we have solved. Okay, now ask yourself, okay, the new signal, what operation that have been involved in it? Is it time operation? Is it time shifting involved? Is it time inversion involved? Or is it time scaling involved or not? Okay, or combination of them. Okay, so this one, try to answer my question yourself. Okay, try to think. And you see this method tree, even without having the information in the beginning, whether time inversion, time scaling, or time shifting happen, we can actually solve it method 3. Okay, but in method 2, for example, you need to able to factorize, and you need to able to identify, then you will make a proper drawing. Okay, proper sketching. Okay, so if you make if you identify it wrongly, then finish everything. Okay, so this why method 3, even though it takes some time, but you you will tend to make less mistake. Okay, so with that, we finish this lecture. Okay, I will continue later on about these amplitude operations. Okay, thank you very much, and see you in the next lecture.